Hello students, welcome in my channel Amazing Team Path. So student, today we are going to discuss very important topic, electronic configurations, atomic or orbital diagrams. So very important discussions we are going to do in today's lecture. So student, what is the electronic configuration and what is the atomic or orbital diagram? So electronic configuration is actually what? So the name indicates that the electrons is there and their configuration means arrangement. Keep in your mind. So the meaning of electronic configuration is electrons arrangement. Okay, electrons arrangement. But now question is that how this arrangement is there? Electrons arrangement. So this arrangement is in the systematic way. So systematic way. Okay, so the arrangement is in the systematic way. This is very important. What is the electronic configuration? Electronic configuration is the concept in which the electrons arrange in a systematic way. So this is the electronic configuration. Understand? Now, how the electrons arrange in the systematic way, that also we are going to understand. So the electrons arrange in the systematic way by the different rules. Okay, so that the name of the scientist Niels Bohr. Okay, so Bohr's theory actually helps to understand the arrangements of the electronic configuration. So as per his theory, the number of electrons present in the different shells is calculated by 2n square rule. 2n square rule. Okay, so this is very important rule, and by this rule we can easily understand the number of electrons present in the different shells. Now let us discuss what is the shells first. So consider this is one atom and the circles. Now you can see the circles is known as the shells, or it is also known as the orbit or orbit. Okay, so this name is you have to keep in your mind, shells or orbit. Okay, so these cells, suppose this is the nucleus of an atom. This is the first cell. The first cell is known as the K cell, then L cell, second one is the L cell. If more is there, then M, and then another one is there, suppose is, then that is the N cell. In this way, the naming of the cell. So the naming of the cell is K, L, M, N, and so on. Understand? So K cell means the first. So K cell is the first cell. L means second cell. M means third cell. And N means fourth cell. So these things you have to keep in mind. Correct? So you have to keep in mind this thing. Now this is what? This is the N. If N is equal to 1, that is the K cell. If N is equal to, this is the L cell. If N is equal to 3, means M cell. And N is equal to 4, means N cell. So this concept you have to keep in your mind. Now, as per the Bohr, what is the rule? 2n square. So already we studied this concept. So 2n square, as per the 2n square, just use for the K cell. If you are going to use for K cell, the value of K, in that n is equal to 1, already we have discussed, this is the first cell. So 2 into 1 square is equal to 2 into 1 is equal to 2. So number of electrons, this is the formula for number of electrons. To find the maximum number of electrons in the different shell. So this formula is very useful to find the number of electrons in the different shell. So in the first cell, how many maximum number of electrons will be there? 2. Similarly, if L cell is there, you can find as per the rule 2 into 2 square. So 2 into 4 is equal to 8. Similarly for M cell, 2 into 3 square, 2 into 9 is equal to 18. And for N cell, 2 into 4 square is equal to 2 into 16 is equal to 32 electrons. So this is very important, students. So you can easily understand the electronic configuration by this rule. Now you come to know that in the first cell how many maximum number of electrons is there? 2. L cell 8, then M cell 18 electrons, and N cell there is 32 number of electrons. If all the things are clear for you, then we are going to proceed the further part of this topic. So here I am going to tell you the further part, that is the electronics diagram. So how we are going to draw the electronics for orbitals diagram? Suppose examples, one examples we are going to discuss. For example, examples of carbon. Consider carbon. Okay, so carbon atomic number is 6. Now how the electrons are going to fill in the 6? If the atomic number is 6, how the electrons are going to set up as per this rule? Means how the systematic arrangement should be there. So in the K cell, see, so in the K cell, how many electrons will be there? Maximum capacity is 2, you can see here. So in the K cell, 2 electrons will be there. Now carbon is having only 6 electrons. Now how many left? Only 4. So next cell is the L cell. In the L cell, how many electrons capacity? 8. But carbon having only 4 after this 2. 6 minus 2, only 4 left. So 4 is there. Correct? Now what will be the electronic configuration? 2, 4. So it indicates that this is the first cell and this is the second cell, and the electronic configuration is 2, 4. Understand? So 2, 4. Means first cell only 2 electrons, second cell only 4 electrons are there. So this is the way how to write the electronic configuration. But if you are going to draw the orbital diagrams for this, let us see how to draw the orbital diagrams of the same example, carbon. Now let us check. Carbon, how many cells now? You understand this. So once again I am going to write here. So electronic configuration is 2, 4. And now you can concentrate here. It is very important discussion. So that 2, 4, how to draw? This is K cell, this is L cell. Understand? Now we have to draw the orbital diagrams. Center, first cell and second cell. Okay. In the first cell now 2 electrons is there. I am going to show 2 dots, and in the second cell 4 electrons are there. So I have to show 4 dots. So that much easy work is there. Once you know the electronic configuration, you can draw the orbitals or the atomic diagrams very easy way. So this is your first cell K, and this is L cell. Correct? So in the first cell 2 electrons are there. In L cell 4 electrons are there. In this way you can complete the orbitals diagram. So this is one example. If you want more, we will take another example. For example, for sodium. Sodium symbol Na, atomic number 11. Electronic configuration as per the rule. 2 the first cell, that is K cell. The L cell now 8 capacity is there. So 2 plus 8, 10. But sodium having 11. So one more electron left. So it will be moved in the next cell K, L, M cell. M cell having only 1 electron. Understand? So 2 plus 8, 10, 10 plus 1, 11. So total 11 electrons should be there. If you are going to draw the orbital diagrams, center, first cell, second cell, third cell. Understand? So first cell, only 2 electrons. So 2 electrons, that is a K cell. In the L cell, 8 electrons. So draw the 8 dot. 1, 2, 3, 4, 5, 6, 7, 8. That is the L cell. And in the M cell, only 1 electrons. The M cell, only 1 electrons is there. In this way, you can complete the orbital diagrams or atomic diagrams of the sodium. Understand? So in this way, it is very easy. But the point, what is that? What is electronic configuration? See, this is a systematic arrangement. Right? You can easily understand. K cell 2 electrons, L cell 4 electrons. Here also, K cell 2, L cell 8, M cell only 1. So this is the systematic way. By this way, you can easily understand. तो बच्चों यही था आज का टॉपिक हमारा, इलेक्ट्रॉनिक कॉन्फ़िगरेशंस ऑफ ऑर्बिटल्स और एटॉमिक डायग्राम कैसे निकालने. तो ये पहले हमने डिस्कस किया था इसके बारे में कुछ, तो आज फिर से एक बार मैं आपके साथ में डिस्कस कर रहा हूँ, क्योंकि ये बहुत इंपॉर्टेंट टॉपिक है। इलेक्ट्रॉनिक कॉन्फ़िगरेशन, हम इलेक्ट्रॉन का सिस्टमेटिक अरेंजमेंट्स जो पढ़ते हैं उसको बोलते हैं, ठीक है। तो इलेक्ट्रॉन का सिस्टमेटिक अरेंजमेंट नील बोर नाम के साइंटिस्ट ने दिया था। उसने एक रूल्स अप्लाई किया था, फार्मूला दिया था कि अलग अलग ऑर्बिट्स में कितने इलेक्ट्रॉन्स की कैपेसिटी होती है, तो उसलिए 2n² का रूल माना जाता है उसको, तो हमें याद होना चाहिए। तो वो रूल्स यूज करके हमने अलग अलग एलिमेंट्स के लिए ये जो रूल्स अप्लाई किया, और फिर हमें पता चला कि उसका सिस्टमेटिक अरेंजमेंट कैसे होता है, और साइमल्टेनियसली ऑर्बिटल डायग्राम्स भी हमने उसको निकाल लिया। तो कार्बन के लिए 6 एटॉमिक नंबर होता है, सबको मालूम है। उसमें सिर्फ फर्स्ट सेल में 2 इलेक्ट्रॉन जाने वाले मैक्सिमम कैपेसिटी, और बचेंगे कितने 4। तो के सेल में 2 और एल सेल में 4 इलेक्ट्रॉन। तो वही हमने डायग्रामेटिकली बताया। इधर ये न्यूक्लियस है कार्बन का, ये फर्स्ट सेल में 2 इलेक्ट्रॉन्स दिखाए और सेकंड सेल में 4। ऐसे ही सोडियम के लिए बनाया है। सोडियम का एटॉमिक नंबर 11 होता है। इलेक्ट्रॉनिक कॉन्फ़िगरेशन के हिसाब से देखा जाए तो 2 फर्स्ट सेल में जाएंगे, 8 इलेक्ट्रॉन्स सेकंड सेल में जाएंगे, और जो बचे हैं 1 इलेक्ट्रॉन्स यंग सेल में जाएंगे। वही हमने डायग्रामेटिकली बताने की कोशिश की है कि न्यूक्लियस होगा, फर्स्ट सेल में 2 इलेक्ट्रॉन्स है, देन एल सेल में 8 इलेक्ट्रॉन्स चले गए, और लास्ट सेल में 1 इलेक्ट्रॉन्स है जो हमने इधर दिखाया। तो यही है बच्चों इलेक्ट्रॉनिक कॉन्फ़िगरेशंस और ऑर्बिटल्स डायग्राम। ज़्यादा प्रैक्टिस कीजिए और वे कंसेप्ट आपके क्लियर हो जाएंगे, क्योंकि ये बहुत इंपॉर्टेंट टॉपिक है आपके हायर स्टडी के लिए भी, ठीक है। तो ऐसे ही चैनल को देखते रहिए, सब्सक्राइब करते रहिए, और अपने वीडियो फ्रेंड को भी शेयर करते रहिए। तब तक के लिए गुड बाय।